Hello, I'm Susan Nash, AAPG, and I'm very happy to be here tonight. We have an amazing program in our week 15 of our Pivoting New Revenue and Diversification Strategies. Our theme tonight is new space, new satellites, drone fleets, and energy. To have this all come together, basically talking about the surface of the Earth. And I want to do a few quick introductions. So I'd like to welcome Dr. Kumar, Navulur, Maxar, and Jim Ellis, Dr. Jim Ellis, Ellis GeoSpatial, and John Pantano, and also John Roberts of Airwayz Drones Ltd. I'd also like to welcome Amanda O'Connor of Harris Geospatial. So we have a wonderful group, and I'd like to also welcome Larry Davis, who is a professor at Texas A&M, Texarkana, and his area of specialty is in strategy and strategic planning. He's former dean of the College of Business. Welcome, Larry. Would you like to say a few words?
Sure. I'm looking forward to the presentations again tonight. Always exciting and anticipating what's before us. One thing I like too is your ingenuity of coming up with these titles that we see. It's always interesting. Anyway, welcome everyone, and I look forward to the presentations and the discussions tonight.
It was a long one today. I'd also like to welcome and thank Julie Lemaster, who's our Director of Publicity. So she's been doing a lot to help us get the word out. Really appreciate that. And anyway, so I want to just remind everyone that a few days from now, you'll get an email from me that will have a recording. It will have a link to the recording, and I will make that available so that if you miss part of it, you'd like to watch it again, you can. Also, you'll have everybody's name so you can connect with them in LinkedIn, and also you'll have a copy of the program. Eventually, I'm going to really put these together in a different form and put them together in terms of learnings. So I think it'll be really valuable for all of our intended audience, which are people who are interested in diversification and new revenue strategies. So basically, I really appreciate your being here and like to introduce Dr. Navulur and invite you to share your screen.
Thank you, Susan. Thank you for the opportunity for inviting me here. Today, what I'm going to do is I'm going to talk about new space and how that can be applied to the remote sensing industry. So without further ado, what is new space? I've been in the industry for 25 plus years, and there are some interesting things that are happening in the industry today. And this is what we refer to as the new space. It starts with everything probably most of you heard is what we call democratization of space with the new rocket launches. SpaceX, Elon Musk has really pioneered how often you can actually go to space. And today, if I were to start counting, there are probably 40 to 50 companies that are trying to launch small satellites that can take you to various orbits. One is called LEO, which is low Earth orbit. This is where most of the satellites that take pictures like you see in Google Earth and what Maxar technology does, we typically use LEO. And even with LEO, there are something you can actually do, which is you can go from pole to pole, which is called sun synchronous orbit. And then there are mid-inclination orbits like International Space Station, where you can go in an inclined orbit. And what all this allow you to do is you can actually start taking pictures of the Earth from different perspectives and different times of the day. So the democratization of the space in the past, I'm talking, 5 years ago, you literally had to wait 4 or 5 years before you have to book a launch space. Now we are coming to a point where these launch schedules are available almost a month or 2 months from when you want to start launching these satellites. The second one is very similar to the industrial evolution. It's basically making things smaller, better, faster. So you will see a revolution in terms of small satellites. And these satellites are actually following the principles of basically building blocks. So in the small satellite technologies, the smallest possible thing, you call it as a 1U, which is 10 centimeters by 10 centimeters by 5 centimeters. So you can start building a satellite that could be 3U, 6U, 5U, and you can actually modularize how you build these satellites. So this has been very beneficial because this has cut down significantly on the time you can actually build these satellites. So now you're seeing there are, I would say, dozens of companies building these small satellites with what we call various form factors. And like I mentioned before, this could be 1U, 20U, or even satellites that are much relatively bigger, that could be like a size of your mini refrigerator to a big satellite that size of a bus, for example. So all these things, the development of these modular designs is enabling us to actually create new satellites. And because we are now able to do this, now people are experimenting with all kinds of new, I use the term phenomenologies. So what do I mean by that? So when you see a picture in Google Earth, it's what we call an electro-optical sensor that's taking pictures in red, green, blue colors, if you may. And then it can also take different pictures in infrared and other places. So each of them capture unique information that can be used for various applications across the energy industry, both on the upstream, midstream, as well as downstream. And some of the modalities that probably are interesting also include synthetic aperture radar. The electro-optical imagery cannot see through clouds. This is where the SAR imagery allows you to penetrate through clouds, but it detects signals differently. So you need a whole different technology. How do you interpret the radar images? And then there are new technologies that are coming online that can actually detect various greenhouse gases like methane, aerosols, and others. So if you're in that area where you're looking at environmental concerns from various operations of energy, now we have these hyperspectral sensors or different kinds of sensors that can detect very fine details of what's happening in our atmosphere. So this is part of this whole new space revolution, is we are now able to bring in these kinds of spectrometer sensors that can detect very finer details of what's happening on the planet as well as in the atmosphere. I already touched upon the orbital modes. Typically, when you launch a satellite, you launch them in the low Earth orbit. And then there is something called middle Earth orbit. So the low Earth orbit is between, let's say, 0 to 1,000 kilometers from the Earth. And then between 1,000 to 30,000 is what we call MEO, which is the middle Earth orbit. And then above 30,000 is where most of our geostationary satellites are. If you're talking about communication satellites, if you have direct TV, most of these satellites sit in one location in the geostationary orbit, and then you can actually communicate back and forth with these satellites. So the new space is now allowing us, in terms of technology, to actually launch satellites in LEO, MEO, as well as these geo orbits. So far I've been talking about satellites, but the key thing is we should be able to download the data onto the ground and do something with it. So there are a lot of innovations that are going on with ground infrastructure. You see the term RGT, which is a remote ground terminal. And this is where there is a whole business model on how fast can you talk to these satellites. And in real time, can you talk to them, task the satellites, take a picture, bring this data down, and do analytics. It could be AI, ML analytics. It could be traditional analysis. But there are several new space developments that are happening that's allowing us to basically talk to these satellites, bring the data down, and then things like the cloud computing. And then there is this whole new technology about edge computing. Think about it as your smartphone, iPhone can be on the edge, where now we are building processors that can actually take all these data and do the analytics that will help you make decisions in the field. So if you were to step back and summarize what this new space is all about, is there are numerous technologies that are happening in this space business, which include the rockets. And also, by the way, I forgot to mention 3D printing. There are manufacturing a lot of these parts using 3D printing. And then various sensors and phenomenologies that can capture about the things that are happening on a changing planet. And then the various orbital planes that will allow you to collect information multiple times a day, or different across the geographies, coming back multiple times to gather this valuable information. And then the ground infrastructure that can help you actually get the data down, assuming you have the analytics engines that they can actually process the data and provide the information you're looking for. So from Maxar perspective, we have been launching satellites since 1999. What we have done is in 1999, we launched our Iconos satellite at 80 centimeter resolution. Now our latest generation satellites, they all collect 30 centimeter class data. And then the second one is the spectral bands. I was talking about red, green, blue, how you take a picture there. Our satellites can capture in near infrared, shortwave infrared, and they provide some valuable information for a variety of applications for oil and gas and energy market. And then now you have these satellites flying 700, 800 kilometers from here. How accurate is an object being detected from these satellites? So this is an improvement in the industry. Today with our satellites, we can detect any object within 3 to 5 meters of where it's supposed to be. An example would be is if you're looking at a leak, a pipeline leak. This is an example of methane sensors. If it's off by 100 meters, it's no good. So there's a whole technology Maxar has been working on where we ensure that the electro-optical imagery we take in visible infrared and shortwave infrared can be very positionally accurate, so that if you're doing inspection of oil basins, if you're doing environmental impact assessment, the information you create will be positionally accurate. And then the last thing I would like to mention is that a lot of these satellites are designed with 10, 12-year lifespan. So they can actually last for a long time. And in general, there is, if you look at what we're going to do next year, we're launching our next generation satellite Legion, which will come back up to 15 times a day. So this is what you can expect if you're thinking about how well can I leverage new space technologies. There'll be a lot of data coming from Maxar and other commercial players, and there will be a lot of applications, not only mapping, but also monitoring. So which brings me to what are the various applications we can do for oil and gas. So in this particular case, as I quickly mentioned, this new space is going to enable us to capture our changing planet with multiple phenomenologies. EO in this case stands for electro-optical, which is the regular pictures you see in Google Earth, but also the information in infrared and shortwave infrared. And then synthetic aperture radar, this can see through clouds. And this is very valuable in terms of doing both nighttime as well as daytime on what is happening on the ground. And then there are new companies like Hawkeye 360 that are also talking about radio frequency signals. And if you're trying to communicate, if you're trying to identify signals such as cell phone coming from a given place, these satellites will be able to provide you very precise location of what is happening in a remote oil and gas field, let's say in Wyoming. So now I talked about, okay, now we are launching all these satellites. Our Legion constellation will have 6 satellites coming back up to 15 times a day. What does it mean for oil and gas and energy market? Now we can actually start talking about mapping oil basins. I mean, if you're talking about Permian basins, which is a huge area, now these satellites can actually capture 30 centimeter data, and you can start monitoring it on a very frequent basis. And with multiple access in a given day, if there is a disaster going, we should be able to actually monitor almost on an hourly basis what's happening in the field. One of the interesting things which we had a challenge with our satellites in the past is we always go from pole to pole, which we call sun-synchronous orbit. And a lot of the pipelines go in multiple directions, east, west, north, south. So if you had a pipeline going east, west, we would have difficult time tasking our satellites to monitor all these pipelines. So with this intraday revisit and middle inclination orbits, now you have satellites that can take pictures any time of the day, as well as in any direction on the planet. So monitoring the pipelines is a reality with these new space developments. I briefly touched upon emergency response. So if there is something that happened, for example, in Beirut, where the whole thing blew up, now we have these satellites coming in every 40, 50 minutes, and you can actually have what we call situational awareness on what's happening on the ground. And with the developments in the infrastructure I mentioned before, ground infrastructure, you can actually get the data down quickly and give it to the first responders so that they can actually know what's happening in a given area and how the whole area is recovering after the disaster as it progresses. The last one, which is very critical also, is the industry is slowly turning from taking pictures to accurate information in 3 dimensions. So we have been doing digital surface models, digital elevation models with our satellites. Now we are in a point where we can actually capture the entire terrain of the Permian Basin as an example, and any changes within the elevation model, or we can actually do that using satellite data. This is useful for moving heavy trucks for new exploration or trafficability of a given path in a given area. So if I step back and if I were to summarize these new space developments, which includes the rockets, the new satellites, new sensors, and the ground infrastructure, will provide you new opportunities to collect data with revisit or refresh of any place on the planet multiple times a day. And that should open up a variety of opportunities through the entire energy pipeline, all the way from upstream, midstream, and downstream. So yeah, that's what I had to share with you, and I'll wait for any Q&A at the end of the session. Back to you, Susan.
Well, thank you. That was really great. Thank you, Kumar. It was so interesting, and it was a great overview of how things are changing and where the opportunities are, and actually what we need, how we need to coordinate the data. Well, I'm happy to introduce our next speaker. That is Jim Ellis of Ellis GeoSpatial, and he will talk about what satellites do and how they can actually work for you. So, Jim, would you like to share your screen?
Yes, do you see it?
Perfect, excellent.
Okay, thank you, Susan. So I'm going to talk about tonight what do some satellites do and how can they work for you today. So we're going to go over some basics and talk about the value of declassified film, look at this multispectral thermal infrared radar, touch on DEMs and how they're used for ground deformation, and then look at a new remote sensing textbook if you want to teach yourself how to better use imagery. So here we're looking at a profile of the Earth, and you can see sensor locations. You can have mobile sensors, drone sensors. I'm only going to talk about satellite tonight, and then there's different types of sensors, and I'm only going to talk about 3 types of passive. The film and multispectral depend on energy from the sun to illuminate the feature. The thermal is capturing energy emitted by the Earth. And then over here in the active, we use radar, and it has its own illumination source. So we're looking at a satellite image from 2014. You see it's a really well-developed field. You'll see in some of these slides in purple what it costs. So a lot of the regional data is no cost. So why use declassified film? So let's say you're working down here on an environmental project, or you had an old well that you couldn't fit into this. If you go back to these declassified films, this is 1979, you can see there's a lot of development there. In some parts of the world, it goes back into the 60s, very high resolution data collected for classified purposes. So you can see what we saw in the past doesn't look at all like what we see in the present. This is a graph showing wavelengths, very short on the left or very long on the right. And I'm only going to talk about this area of the wavelength spectrum. You and I only see a little bit of it, the visible. I'm going to talk about the infrared, which is near infrared, shortwave infrared, then thermal IR, and then a little bit about radar. So the next slide enlarges this area of the chart. And so we're looking at going from 0 to 15 micrometers. And on the left side is atmospheric transmission, like how well does this wavelength go through the atmosphere, bounce off a feature, and then go back to the sensor. And you can see that blue, green, red, what we see is the atmosphere is very transparent to it. But as you go into longer wavelengths, you have these blockages due to molecules up in the atmosphere. So we only have a few atmospheric windows where we can actually build sensors to detect what's going on here. And so if we look at the bottom, there's all sorts of satellites down here. We're just going to look at Landsat. So when they talk about bands and multispectral bands, band 1 is reflected blue light. Band 2 is reflected green light. When you come out here to 5, that's just this little area of shortwave infrared, and then band 7. So number one, I recommend anybody that's going to go anywhere, you got to use Google Earth first, because it's just an incredible resource, but you only see natural color images that's generated from the data. And so this is just looking at bands 1, 2, 3, which is reflected blue, green, red. And so this is what the bands actually look like. So this is reflected blue light, reflected green light, reflected red light, and then you'll see near infrared is dramatically different. It's very sensitive to the plant vigor. And then we're out here in the short wave, does a great job delineating water versus land. And then the band 7, the longer short wave, which is really good for clay detection and moisture in the canopy. So if you just go to Google Earth, you get a good looking image. But if you take the same data and you process it, even on Adobe Photoshop, you can come up with a lot more information targeted to what you're looking for. And you can pick out different band combinations. So here's a color infrared, which is showing you the vigor of the agricultural fields. This is total infrared. So these are bands that you and I can't see. And often, especially in geology or when you're looking at plants, you see a lot of different patterns, and earth scientists are really good at figuring out patterns. This is a combination that uses 2 infrareds and 1 visible, so vegetation vigors in green and water shades of blue to black. And then because these are just digital numbers in this grid, we can do all sorts of mathematical gyrations with them. And you can see before man came and built this canal and plowed up all these fields, there's an alluvial fan there that really altered the soil composition here versus there. So if you're doing work in either one, this image shows that this area is different because of the alluvial fan. So we can do the same process zooming in to Maxar's QuickBird, an archived image. We're just seeing a high resolution natural color. And if you process this, you get the 4 bands, you can do something like that. And so you can see there's a lot more information by just processing the same data and bringing out what you want to see to pull out these patterns. Another thing is, if you're going to use multispectral, there's hundreds of thousands of scenes around the world. And so here we are in Nigeria in the Benue Trough. And this green is a stream coming down and agricultural patterns. This is on Google Earth in 2018. So I go out and for free, I download the image from the USGS and make it into a color infrared. And I see now the stream. These are agricultural patterns, but I don't see anything in my area of interest. I can go farther back in time to 1986. And this is what you see. Before mankind came along, changed the agricultural practices, you can see a lot of structure. That's important for soils, groundwater exploration, oil and gas exploration. So always evaluate many scenes. Now we'll move into thermal IR. And this Terra platform has been up for 20 years. It's an incredible system that was built. And on board is the Astra system, and it collects what we've been looking at: visible, near infrared, shortwave infrared. But in addition, it collects 5 grayscale images of the Earth emitting thermal infrared energy in 5 different bands, and they're numbered 10 through 14. So let's look at these bands and see if we can do surface temperature and lithology. And so now we're over in Tanzania. We're looking at color infrared. So red is vigorous vegetation. This is a tough place to map geology. But fortunately, back in the 50s and 60s, when geologists were doing a lot of field work, they went out there and this is their map. The question is, can we improve upon this map? And then they did really valuable stuff. They collected samples and they dated it to very old 600 million year old rocks. So we go back, we get the astrothermal, and this is a nighttime surface thermal image. And you can see that the digital number is what's in every single pixel. We run it through this formula provided by JPL and USGS. And all these areas of the outcrops are like 20 to 24 degrees Celsius. And you can see it does a great job of picking out this band. And so what we know now is we can take that map and the dates and say, okay, this is the probable location of the granite gneisses because they have a high thermal inertia. They're relatively warm at night. We'll take another example over in Afghanistan. So we're looking at a map, a regional map this is basalts, and over here is clay and shales. The value of this is the ages. And this is a digital elevation model. We're only interested in the exposed rock, not out here where it's alluvial. This is an astrothermal band. You can actually see it's a mosaic of 3 different scenes. And because they're just digital numbers, we can do ratios. So we take 14 divided by 12, and rocks that are bright are quartz rich. And so I can go through, mask out all these areas I'm not interested in, so it shows the agriculture. But within this, the red are quartz rich rocks. I can use another formula and come up with carbonate rich rocks. And then yet another formula that some USGS people put together, and these are where the basalts are. So using GIS, I can combine my 3 rock types and make a new map, a new contribution where I've got quartz here, carbonate over there, and mafic here. And so you can see we've added value to this map that shows us some structure and ages. So now we'll move on to radar. And on our graph, you can see with the wavelengths get really long. So we're up to 0.5 meter for the wavelengths. And all these systems here are satellites that are collecting radar data. And there's even new ones now doing some remarkable work. We're only going to look at band X and L. So we're in Death Valley, and we're using 1 radar antenna to acquire imagery at different wavelengths. So down here is the Landsat image showing alluvial fans, a mountain range. And this is X. This is only 3 centimeter wavelength. Has a lot of interesting patterns here. We go to a longer wavelength, L band, see it's different. It turns out it's related to the surface texture, the water moisture. Well, it turned out that it's too complicated for most people, and it didn't sell well. But what does sell is using 2 radar antennas to generate a DEM and to measure ground deformation. So here we're looking at the space shuttle, and we've got an antenna here that lets out a radar beam, captures it, but also out on a boom, there's another antenna. And so that difference in distance enables us to map topography. And over here in today's world with the World DEM, they built a 12-meter grid using satellites flying in tandem that are building this DEM. And so what's amazing is these DEMs cover the whole world. And this is one from Aster. And if we zoom into the Red Sea, you can see you've got a lot of incredible information, plus bathymetry. And a lot of the bathymetry comes from radar altimetry. But what if you're in an area and you don't see anything in your DEM? So we're just looking at this flat area. And we say, well, what can we do about this? Well, you can model the drainage network on the DEM. And typically, most streams go from high to low. But notice these contorted patterns. And so this is what we call drainage anomalies. And so they could be targets for exploration or groundwater exploration. And the latest thing is using radar for ground deformation. It's called interferometry. So here we're looking at a freeway in Italy, and we're looking between 2009 and 2012. And those red dots indicate over that 4-year time period, the area was sinking 10 millimeters a year, which is 1 centimeter a year. And another example in West Texas, here we've got an aerial image, and this is the radar interferometric map. These colors represent how much subsidence has occurred in this field. So you want to take note of L, M, N, and O. Those are the targets we'll see on the chart below. And where it's red, saying that the ground deformed subsided 4 centimeters in this time period. Well, the time period goes from 2015 on the left out to April 2017 on the right. And the bar graph is the oil production, which is the right axis. But at the same time, this radar is collecting at L, M, N, and O points, and you see the subsidence through time. That's over on the left axis. Then at the very end in April, some really pretty intense subsidence, and then up at the top, these stars, and those are earthquakes. So if you want to try this, this is advanced remote sensing. You got to subcontract it, or you can go back to graduate school. And so I'll wrap up with this new textbook. Floyd Sabins wrote the classic geological remote sensing textbook in the 80s, and he did his 3rd edition in 1997. And so it's a classic. It's really strong on principles, on geologic interpretations. And Floyd, I've worked with him for about 35 years. He and the publisher approached me about becoming a co-author and updating all the technology and expanding the applications. So I did, and it's been published in April 2020. And you can evaluate the textbook as an ebook for only $12.70 for 1 month. That's amazing. And so what I put in the system is not just a textbook, but there's a lot of open access downloadable material that I'll show. And the whole thing is structured to support self-taught students. So this is looking at the chapters. Compared to the 3rd edition, these are all the new chapters are in that light orange. But you see, we've already talked about satellite photographs, multispectral, thermal IR, radar. But now we've got LiDAR in here, drones, image processing, GIS, and a wide variety of applications. It's a pretty intense book, 524 pages. So you can learn a lot. I learned a lot just writing it. And so this is this downloadable remote sensing digital database. When it's unzipped, it's 6 gigabytes. And you download it from the publisher's website. They're all zipped. But let's say we have a big discussion in geology in Wyoming. So what I provide is all the Landsat, the geologic maps, the DEMs, and you can process the data yourself with open source free software, or we have a good deal with Harris, L3 Harris, that you can get a 30-day free license to process the data. So you can see this is Landsat. We've got the thermal IR that I talked about, radar, there's drone data, and hyperspectral. So it's a good rich data set that can help jumpstart your understanding of image processing. So if you have any interest in teaching yourself about remote sensing, you can go to this website, and I made an intro video that you can download, and it shows all the things you can get, and then test it out for just Reddit, see if that works. So that concludes my talk. It's what are some of the things satellites do, because they do way more than what I showed. And the question is, yes, they can work for you today. If you've got any comments or questions, please contact me. Thanks.
That was great. And I'm going to order the book right away, and I'm getting a full one. I actually have, I think, the 2nd edition. I remember taking when I used that when I took remote sensing as an undergraduate. It's a great book.
Yeah,
like the earlier editions.
Yeah, I used the Sabins book when I was in grad school. It's absolutely phenomenal. And because I'm at L3 Harris, just to comment on the complexity of SAR data and working with it, we have some guided workflows now for working with SAR data, because as you know, it can be really difficult. And we're kind of a dual remote sensing household. My husband is upstairs and he works for Capella. which is a SAR small sat company. And I think they're going to have tools that are very friendly to the end user to be able to make answers out of the SAR data as opposed to having to spend days just pre-processing.
That's just amazing. It opens up so many different opportunities for geologists, and we haven't even talked about. We will a little bit later. In earlier times, talking about outcrops and just what people are doing to connect and correlate the outcrops with subsurface models.
Yep. So stop sharing. I don't.
Well, that was great. Well, thanks, Amanda, too. I really appreciate your being here. That's great. So do you and your husband ever get into long debates about?
We actually met at the former RSI that some of you may know. I think Kumar knows Adam from his Maxar days. So yeah, we've both been in the remote sensing industry. We had the same advisor in grad school, just didn't even know each other. So yes, we do have a few arguments, but right now it's been hyperspectral downstairs and SAR upstairs lately. So
as well it should be.
Hey, Susan, can I say something?
Yeah, absolutely.
Hey, really enjoyed. I'm glad you're, I'm signed up. I heard Kumar's and also the previous lecture by Ellis. Yeah, I'm just getting into remote sensing. In fact, I have an AAPG talk, if you remember, for coming AAPG online.
You do? Yeah, thank you for mentioning that. Also, Sharma is
and I'm giving up how remote sensing is used in oil and gas. But I'm not remote sensing, not even close to 1% of these guys. But imagine how my talk would be, you know. So basically, I'm sucking up everything I can, and I'm quoting some of these discussions. So that would be interesting, you know. I'm learning every day. I really enjoyed James' talk and Kumar's talk today.
Thank you. Yeah, that's great.
I might pursue them. If you post presentations and addresses, I might communicate with them and learn from them a little bit because I'm actually going for a PhD at Texas A&M as we speak.
Great. Oh, that's great. Well, congratulations to Sharma. And Sharma's also head of one of our TIGs, technical interest groups. So anyway, I want to turn the floor over to John Pantano. Welcome, John.
Hi, how is everybody?
We talk about characterizing minerals and moisture for economic and environmental stewardship on Earth and in space.
Thanks. So this is going to be a little bit different where I'm going to give you some case studies and really just things that I have found interesting. I'm a petroleum geologist, but I've also worked inside mining, and I've also done an incredible amount of work in terms of environmental remediation. And I've built several wetlands to mitigate damages to watersheds. So what I found out is this lake right here, they were doing the time lapse. And I think that's one of the best things that's been happening with satellite imagery or remote sensing is now we're getting many more frequent, high quality data points. And we can look at differences in the shape of either water bodies or the shape of the Earth as it responds to different events. And so here, they were just watching what the shoreline actually was moving back and forth through time. And what's really interesting about this, and that I always have used in my petroleum geology and even in the minerals, is these lakes actually are a reflection of what happened down deeper in the Earth. So this isn't a crater lake, but this is basically a collapse feature or a depression that was near the magma chamber of a volcanic system in Italy. Then, you know, when I was talking to Susan, she said about space, and my best friend from University of Michigan, almost 45 years ago, he's now running this lab, and Pat gave me several really interesting observations of current work that they're doing. And so I'm just going to share with you some of the things that I found fascinating that the Space Physics Research Lab was involved with. This is actually asteroid, or I don't even know what it's really called, because it's been stripped of its mantle and of its crust. And this is basically just the core right here. So I was having a discussion with some friends, and it was like, well, how do you just get a core? You know, that's a big chainsaw, or there's something really extreme that went on here. And a lot of people are very interested in this because it tells us something about really the dynamics and the elemental composition of the core. And so what's interesting about this core is that there's a whole bunch of gold on this body. And they think that if they actually went up there and started to harvest the gold, it would basically get rid of the demand for gold and crash the price of gold and everything else. But it just goes to show that when we're trying to figure things out on the Earth, we sometimes have to go up and look at what's in space. And we might have some good analogs that we can then use to try to improve our understanding of what's going on in the subsurface, and or what's outcropped, and or what we can get by either deep mines or actual wells. This was something that, especially for people involved in petroleum and also in organic matter, they're basically building probes that this instrument right here might take up half of a laboratory, or would have taken up half of a laboratory. And that's actually going on a mission that's going to Titan. And Titan's got a very unique atmosphere, and their fluids are quite interesting, and I'll go and talk about that. But one of the reasons that they're studying it is this lab right here. The gentleman is interested in trying to find out if there's life, or was there ever life on this moon because of its extreme, I don't know, atmosphere. So let me just show you basically, this is the atmosphere. So this is basically ground level. This is temperature. So basically this is minus 200 degrees centigrade because this is in Kelvin. So basically it rains methane. There are actually methane lakes. And it's a very complex system, and it's, you know, all controlled because of the way that the atmosphere and the base of the, or the top of the sediments is staying very, very cold. And we've got a direct analog. And one of the interesting things about this is, you notice how whether it's moisture, water, or methane, you can actually see some of the things that are going on in the subsurface by the way you actually have topography. Several of the people ahead of time have talked about how important topography is, and I can't stress, every field of work that I've ever worked on, the better you have that topography to look at surface drainages and or abrupt shifts where there's erosion, you can usually find some very critical geological feature. A previous person spoke about the soil moisture maps. What's really interesting about what's going on here, and I couldn't find anything that was recent, but soil moisture from satellite is pretty interesting, but they're actually coming up with ways to instrument and to better calibrate this model. So a lot of this stuff can only tell you what the moisture is in the first 0 to 3 or 4 inches or 2 inches or 6 inches. But really most crops and most things that impact us, you have to get the moisture down deeper. And by them starting to set up different labs throughout the world, they're getting a better calibration data set for them to actually be able to better give us estimations of how the soil moisture is not just at a single time, but how it's changing through the seasons. And I thought I would end with, this is my backyard. And basically this is Butte, Montana right here. This is Berkeley Pit, which is a Superfund site. But then here is the Continental Pit. And it's amazing what aerial photos and drones that we've actually used as we've watched both the economic actual harvesting of the copper and molybdenum out of the mine, and then how we actually look at the Continental Divide basically runs through here. This is all a processed water stream, but this is basically a tailings dam that basically grows between 2 and 7 feet high each year, because whatever's dug out of this pit has to be ground up, and then they bring it up here, and by putting it at different ends of a delta, so they have a pipe that basically is the outflow of what you would call a river, and they can basically make this beautiful sand body. And the high resolution DEMs that we get here actually help make sure that this dam stays safe, so that these 100 feet of sand doesn't come down into the operations. What's also interesting is a little bit west of me or east of me is a place where you actually can find rocks. And it wasn't found with satellites, but it's being able to be confirmed otherwhere, where these are the rocks that actually show up on the moon. So it's one of those things where tying the space component into our earthly component, we can understand the geology of our world a lot better. Thanks, Susan.
Oh, this is so great. I just love the way all these flow together too. And that's, what is the name of the pit?
So this is the Berkeley Pit.
Uh-huh.
So there's 50 million gallons, billion. I forget these numbers. It's billions of gallons of about pH 3 water. And then there's a fault right here. And so this was all sulfidic. And then this is another active copper mine. And this is all alkaline over here.
Wow.
And this is called the Continental Pit. Montana Resources operates this.
Wow.
BP and ARCO was this was the Anaconda Mining Company.
Wow, it's super interesting. I spent some time doing copper in Arizona, and one of the pits, they claim to be the most beautiful pit in the world, the Lavender Pit in Bisbee. I don't really know why they called it beautiful.
Yeah, in Brazil, there was a major accident that such a pit was breached, and there was it was all over the news last year.
I think that was a tailings dam, and not pits are usually in hard rock, and usually they're below the water table. These type of tailings dam that have the residual from the mine after they've taken out the ore, actually these are the things that there are damages. And it was interesting because several people after the fact said the radar had picked up the deformation, but it doesn't help us to know after the fact. We put in fiber cables and other sensors to watch ground movement so that people can react to it ahead of time.
Right, and so, yeah, it's interesting. I'm really looking forward to our next speaker, because what I think is a really fascinating area is where drones work together to complement the satellite imagery and to be able to do things like evaluate moisture levels and water content and all those other things. So anyway, I'd like to introduce John Roberts, Airwayz Drones Ltd. And so I'd like to invite him to share the screen. You might have to stop sharing yours.
I can't find how to stop sharing mine. I apologize.
Uh-oh. Well,
I might have to quit and come back.
You can do that, but you should just be able to mouse over on the bottom and it'll say stop sharing.
I'll be back.
Okay.
Thank you, Susan.
No, welcome.
Yeah, I'm going to be sharing from an Adobe Word PDF of this. My PowerPoint just crashed, so this might be just a little bit out of date. But thank you everyone for the opportunity. So I'm John Robertson with Airwayz. I'm on the board of advisors and also represent their U.S. business, which is really in startup mode right now. We have a small company based primarily out of Israel. All of the principles and development and kind of the thought leadership and ingenuity is coming out of Israel. We have been in business for a few years, really in startup mode. The whole value purpose and the whole value principle that we operate under is it really, the drone market from a hardware perspective is becoming kind of like the PC market was in the late 80s. Kind of ubiquitous hardware capabilities are there. Lots of different, some vendor shakeout, et cetera. Of course, you have Digi and a few others that are leading the market. But we really look at the software side of the drone market and the capability to really have an agnostic view of of drones. And then from a cloud-based solution to really allow fully autonomous mission capability with multiple drones. And so that's really kind of our value statement, our value proposition. So when we looked at the market, we saw really a few problems, that there really wasn't a platform that allows drones to efficiently and safely integrate to the airspace to do a number of missions. If you've taken the drone pilot course and some of the other things, many of the drones out there now have pilots that are operating on it. It's high cost. It's not scalable, and we thought that there was an opportunity to create something out of some of the problems you saw today about the manual operations, where you really don't have the opportunity to do fully autonomous missions. They're really not managed. So if you have an obstacle that you can't foresee or you can't program into to a mission, then you potentially have the risk for crashes, etc. And it's really not scalable if I have to have a pilot operating each drone. So that was kind of the basis of the problems that we saw in the marketplace. And really, if you don't have something you can operate off the shelf, and you really start to limit the ability to use drones effectively. We then looked at how we could build a solution that would, of course, solve what we thought was a market need. So we have an AI-informed software. It's agnostic, as I mentioned. It's multi-autonomous for pilot and air control. It was the guys who are writing the system are actually former Israeli pilots and air traffic control SMEs, so they know how to write that and how to look at the way that basically a fixed wing or a mobile wing drone should operate. They have and so we built the capability for fully autonomous. What that means is really multiple drone operations, the ability to really have deconfliction built into it so they can avoid obstacles, etc. And that also allows us, of course, to operate in what we would call complex airspace, such as, for example, a metropolitan area or other areas, or even some of the areas that you guys have been talking about in terms of some of the mining and some of the other things that I was just looking at. The multiple flight capability really means it gives me real-time capabilities in dynamic airspace. So, for example, drones can communicate to each other through an API. If there's a helicopter or something else, or an additional flight going on, they can understand where those are, and they can communicate with those to avoid collisions or to work together, for example, in search and rescue or something like that. It's scalable. The thing that we wanted from a scalable standpoint was the ability to have multiple drones, so kind of a hive approach. You've seen some demonstrations, probably, light shows and other things that have happened. Those are all pre-programmed for exact movements. We really wanted something that was more dynamic and allowed you to make real-time decisions or have real-time, as we mentioned, obstacle avoidance, etc. That we thought that we wanted to build into the solution. So and the fact that I don't have to have a pilot operating one of those, of course, it gives me the ability to scale and also to have round-the-clock missions without worrying about fatigue and other things that come on with just trying to manage multiple pilots trying to do those things around the clock. So the kind of things that we look at this, where this fits in the marketplace, we look at a perimeter or asset monitoring. You've got a fence, you've got a wall, and you want to examine that. Assets, of course, could be anything. And in the energy business, we were looking at. I was involved in a previous life on a big oil opportunity, and we were looking at drones for managing both herd movements on large, and Africa, et cetera, and looking at how those things work. And so both the asset that I own, but also assets that I want to protect, and making having real-time information around those and impacts that I may be having from an ecological standpoint. The inspection part of it is really, of course, uses the AI piece, and some of the work that I just saw Dr. Ellis doing around time-based, or some of the other ones that I saw John doing about time-based changes, and using AI capability to do inspections, looking for changes, looking for impact to higher risk operations, where I might look at changes in temperature or other areas, and look and the ability to do hopefully some predictive preventive maintenance or predictive modeling around where I might start to have a problem in some high value equipment or high risk areas. Of course, remote operations, search and rescue, that comes also in a point about the ability to operate in high winds. We've got a high wind capability that, first of all, it can look at, if the weather's not suitable, it can change the mission, but in high wind, we've done some test landings in pretty high wind and very high levels of accuracy, within a few inches of being able to land where we intend to land if we need to. But for search and rescue, we also have the ability, again, to cooperate with other vehicles and to have joint operations, even if it's not part of our system. Of course, in fleet management, I think you understand what that would be. In the defense, in Israel, this was used very recently in some of the issues with COVID, and some of the other things were around crowd and other management when it came to some of the high risk areas, and some things there that they saw were really impactful, and right away was used in that area to really impact something on short notice, and to put assets in the air, and to have a risk management approach. So those are some of the areas that we look at. Of course, there's the fact that it's open, the fact that it's a very programmable API, that we think there's a lot of opportunities in different areas, and one of the reasons we thought it would be fun to talk about to you all tonight. So we also, the thing that we've also looked at this, if you're familiar with drones and boxes and some of the different costs of drones and software, we really are using pretty much off the shelf, a few $1,000s for a drone, very, very inexpensive for the charging boxes, et cetera, that allow us to put a lot of assets in the air, to have them fully managed, but also to have a very, very cost-effective solution. So a couple of the key features, and just I'm not going to drill into this too much, but you can see a couple of things on the bottom of your screen. Multiple route optimization, the ability to have different ways to get to the same solution. Deconfliction is very important for us. Anti-collision is very important in terms of asset protection, drone protection, people protection. And the continuous operation bit about one drone can take over another drone's mission. The average drone having a battery life of about 15, 20 minutes. But the ability to have continuous operations and have those take over and have that pre-built into the system to us makes a lot of sense. So a few other things out there that we think that make real good sense from a managed operations standpoint that we are working on. And part of our product roadmap is, of course, continue to modify this to grow, look at the market opportunities, and to see if we can't continue to grow with the business. We think it's a big opportunity, and how we think we're pretty well positioned to do that. So that's all I was planning on sharing tonight, Susan. I'd be happy to participate in also the Q&A session.
Oh, great. Well, that was really interesting. And I think that when we think about how the kind of the handoff and the complementarity of the satellite imagery with drone, it opens up even more possibilities.
There's a bit, we're not right now into doing a lot of, for example, some of the analytics that we think are necessary. That's right now, that's a little bit of our scope. We partner with a few folks to how we can use that, because the data here and the data you might see from the satellite images or other sensors that you have would be to start to create a full picture. But the analytics piece is something I've been kind of leading the charge on in terms of something we should look at. But it's really not. It's really we're not quite ready for that, but we certainly see the potential for it.
I have a question. Are you able to get a FAA waiver to fly?
Yes, well, we are. Well, let me make sure I understand your question, Dr. Ellis. We certainly are FAA approved in terms of the flight regulations and the flight requirements. There's a level of airspace that you have to manage in terms of how far, of course, how high you go, where you go, what size of drone you're using, etc. Right? But in general, we've pursued and have FAA licensing for basic operations. But we'd really have to look at the specific application before we jump in and say, no problem, we can do it. For example, obviously in a city or something like that, it would require a whole different level of approval. Right.
Yeah, I just hope FAA cooperates.
Yeah. Well, to be honest with you, for example, if you're looking at like a perimeter application where it's on land that you own and it's or you have right of way to, then you can see some, or even indoors, you can see some. Of course, that's pretty simple, right? But just cruising through a city, we don't see that as an immediate opportunity for us.
Thanks.
About the pilot training, a lot of schools are offering pilot training. What do you recommend? Do you have any recommendation maybe in Houston? Is there any good school there?
I did some work, and I'll have to get the name from you. I did some work with a guy who runs a school out in California to just look at the opportunities there. But our whole model is really the fact that I can program a flight plan, and then I don't need a pilot. It truly is autonomous. There's no pilots. Now there is a controller, the computer screen. You see, there is a control screen, and I can have the ability to do some things with it. But this truly is an autonomous solution.
And that's really amazing. And I guess you just program in the waypoints, and
there's a number of programmable libraries you use depending on, of course, you're using some sort of geopositioning and a number of other things. I'm not the programmer on that one, so I can't give you that. But I'd be happy. The couple of things we wanted to offer was if a follow-on session, we'd love to offer to show a demonstration of this. The one of the drone landing and something with high winds, like 20, 30 miles an hour, is absolutely stunning. Where it's pre-programmed and lands and goes, lands in, if you're familiar with the storage boxes where they have the charging systems, I don't know if you guys are familiar with that, but the ability to take off and land inside one of those boxes and a pretty high wind is a pretty stunning demonstration.
Yeah, my question is more general. It's like not for your company, but for general who wants to learn piloting. So do you have any recommendation in Houston?
Absolutely. You mean in the Houston area?
Yeah.
Let me get back to you on that. I'll take that as an action. Okay. The one I was using, I believe, was out of California, but as I recall, it was anywhere. You could take the courses anywhere, but the company was local and could learn anywhere. I don't think you have to actually. Well, let me back up. If you don't have any access to a drone, or if you don't have any of the tools, and you want to just go rent it somewhere, then you obviously would have to go to a school local to you. Let me I'll take this in action and come back to you with a recommendation.
Thank you.
That sounds good. And then Amanda, I'd like to invite you to kind of facilitate some Q&A right now.
Let me stop sharing.
Thank you, John. That was great.
Thank you.
Okay, I think I'm unmuted now. I think my cat has been occupying my screen quite a bit.
I don't see, Susan, how many people signed up for this webinar thing?
Yeah.
We have about 120.
Oh yeah, I don't want to take up too much time because I already spoke so many times.
It's okay. So Amanda, we've got a few questions in the Q&A, and so I'll let you facilitate.
Okay, so I'm not seeing the Q&A box, so I need to find the chat. Okay. Sorry, I haven't done this too many times in Zoom.
On the very bottom, there's one. I think that might be actually for Maxar or for L3 Harris.
Yeah, let me.
It's like our 5G licensed frequency spectrum renting options. Can they be used for HTS satellite to ground downlink?
Well, I don't see the questions.
Hit the QA button. It might be at the top of your screen. I don't know a lot about drone frequency renting options. Yeah, unfortunately, that's a different part of Harris that does kind of that part of the like beyond line of sight and radio frequency and cellular frequencies. Does anybody else have another thought about that?
No, same thing with Maxar. The high throughput satellites is the HTS aspect of it. And I am not familiar with that side of our business, so probably I cannot comment on that.
Yeah. And just to comment on from the last presentation on, pilots and collecting drone data appropriately. I mean, it definitely getting data, it can be massive, it can be challenging to work with. There's a company called Juniper Unmanned in Golden, Colorado that does a good job in educating people on how to get their pilot's license, and also then they do some contract work. And then we at Harris have a tool called Precision Pass, so you can download your drone data in the field to a laptop, and it doesn't have to be a super powerful machine, but basically it makes sure that you didn't fly too low, you didn't fly too high, you don't have gaps between your lines, that you collected your data appropriately, so you don't have to go back and recollect it, that there's not like shadows in weird places, that sort of thing.
Yeah, thank you for mentioning that. It's Juniper Unmanned. And looking at their website, looks good.
Yeah, they're good. They're good people. They've got good people on their staff. So
well,
like for
interesting. Yeah, go ahead.
Yeah, for people who aren't really familiar with drones, I mean, they're a great tool, but there's a lot of places you can make mistakes. So going with, getting a little bit of training or something like that, I find has been really helpful for a lot of our customers to be able to get better data, be able to collect it faster and get results that they want, at a better speed.
So John, you have a software as a service, and how flexible is it?
Well, it starts with, for example, if you look at some of the major players in the drone world, right? Digi, and then if you've got PX4, which is an open system capability.
Oh yeah, PX40, yeah.
Et cetera. So we work with certainly all the major players, or anyone who's got PX4 capability, which is kind of like the Android of drones, right? So when it comes in that perspective, from a hardware, just working with a drone, and the basic commands of flying a drone are pretty similar. So we work with that pretty easily. Then if it's through APIs, adding on different camera equipment, sound equipment, and other specialized equipment, infrared readers, etc. There's a series of APIs that we have that allows you to do that. Some of the folks that we've been doing work with early on, we've ended up writing the APIs and building those for them so they work with their equipment. But we expect that, you know, that many people will be able to do it themselves. Is that what you're asking? Is that?
Yeah, that's great.
Hey, question for Amanda, like L3 Harris. You work for L3 Harris, right?
Yes, that's correct.
Yeah, but I'm signing up, just like I mentioned, for a PhD program in A&M. I haven't used any processing software. I'm familiar with all the terminology because I'm a geologist for 35 years in oil and gas. I deal with a lot of remote sensing data for my maps, but I haven't really processed any. But when you sign up for as college, I hope there should be some kind of user license for colleges, school for training. Is there a program like that so that I don't have to pay for out of my pocket?
We have a very low-cost academic license program. In fact, we were talking about trying to get a site-wide one with Texas. I know A&M actually has a site license, so if you want to email me afterward, I'll put you in touch with the fellow who maintains those accounts. And generally, when we start people with Envy, if you haven't used it before, we provide you with our introduction to Envy manuals, and there's a lot of online resources for getting started in whatever you want to do. But if you want to reach out to me directly, I'm happy to discuss what you're looking for.
Sharma, why don't we let Jim talk about some of the educational elements, since he has a textbook.
Yeah, there's many softwares out there that are open source, and so even like LeoWorks is out of the European Space Association. That's a good starter, but the big ones like Envy, which is from L3 Harris, ERDAS, PCI. These are really serious software. So if you're going to do something creative and new, you want to migrate to the serious software packages. If you're just going to do color enhancement and basic contrast stretch, a lot of it can be done with this Adobe Photoshop now, which is crazy. And Adobe Photoshop does actually probably the best work with colors. So if that's where you want to stick on a basic, making beautiful, like if you have a drone, you can what is it, Light Shop or Light Store? There's some software that I think Adobe runs that allows people to like saturate the images. So just making great color informative pictures is one thing, but if you actually want to process the data and make something new, then you want to go with the software that's provided by either satellite systems like ESA, or you go to the commercial.
And then I'd like to have Kumar weigh in also in the part of coming that has to do with acquiring images.
Yeah, from a Maxar perspective, you actually used to run a Digital Glow Foundation, which was a nonprofit. And once we became part of Maxar, we are recreating the entire education outreach program. So we have very interesting programs. Now, at this point, I'm actually supporting around 50 to 100 universities where we help students access to our imagery. So again, maybe after this conference, if you guys want to reach out to us, we can provide you the information.
I will reach out to you, Kumar. But how do you get emails, your emails, Connor's and Kumar's emails?
Okay, Sharman, why don't we let other people ask questions, and then, sorry, and then at the beginning, I announced that you'll be getting an email from me that will have links to the presentation and also information about the presenters. And I will not be sharing their presentations. If someone wants to have their presentations, I'd like them to connect with them directly, because that's one of the points of this. And so I noticed that Dave Koger is in the audience. And Dave, if you'd like to talk a little bit, I'd like to hear your point about if somebody is getting started and they want to get the images to work with, what do they do?
I guess I'm unmuted now, is that right?
You're unmuted, we can hear you.
Okay, I'd recommend looking at Google Earth a lot and getting familiar with the landforms. And then based on what you've learned from your observations, that would dictate what kind of software you needed to get to process the kind of images you needed to get, whether they were air photographs or Landsat or Sentinel or some of the hyperspectral or drones. Google Earth is a good place to start. I guess that's all I got to say. Great presentation, by the way. Thank you all.
Oh, those are really good. And I noticed that Sudhir Pai has a response to one of the questions. Sudhir, would you like to speak?
Yeah, good evening. Again, a great set of presentations. Perhaps, well, this to the whole audience, but maybe more in the for Kumar to answer. Maybe I've typed it up there. So you know, when you want to go and get a phone from AT&T, they have this map out there, particularly of the US, of areas where they have very good coverage, but more important, areas where they don't have very good coverage, and blackout areas, etc. Does one exist for satellite, particularly the data coverage area? I'm more interested in places where there is a blackout in general, but particularly, let's say, the Arctic region, where sometimes it's so difficult to get data closer to the poles. So yes, you know, the number of times that as the number of satellites increase, as the coverage increases, obviously the blackout areas are becoming smaller, but maybe based on what you see at today's snapshot, somebody can answer this. Thank you.
Yeah, let me take a shot at it. So basically, there is no area that are blocked out from satellites. There's an international remote sensing treaty that was done in the mid-90s, where from space, you can actually image any part of the globe. And then the next one comes to, because we are a United States company, we have some multilateral agreements with countries. So for example, this will change pretty quickly, but there is something called the Kyle Bingham Law on Israel, where we cannot share imagery that is better than 2 meters. And there are things in process where we might be able to do that. So going back to your question, there are no areas we black out on purpose. If you're seeing areas that are not being captured, it's primarily because there is not enough demand on that particular region. And then as we launch new satellites, especially the mid-inclination satellites, they only cover from 45 degrees to plus 45 to minus 45. So there are some limitations because of the technology, but the remote sensing policy in general allows for collecting the entire planet anytime we want.
That's interesting. So the theory that there's an alien base in Antarctica and the government's blacking out the satellites is not actually true?
No, it's not true. And we actually finished, I mean, I don't know about, actually, I was doing a presentation for Chile, and we had all shots of Antarctica there. And we actually finished a project working with NOAA on creating an Arctic DEM, where we provided a bunch of imagery, and they provided detailed elevation models that are being used for permafrost as well as estimating ice melt. So short answer is no, that's not correct. Everything we collect is available, and we are not prohibited from shooting any place on the planet.
And conversely, just to add to what Susan said, if somebody wanted good data, particularly, let's say, weather data from, let's say, 75 degrees north latitude and above, you are saying technologically and logistically there isn't an issue?
That is correct. And actually, at the poles, we have a lot more capacity compared to equator. Technically, yeah, there are no issues collecting data anywhere on the planet, especially the poles.
That's really interesting. So I have a question for Dr. Pantano. So what do you see as one of the areas of the biggest areas of growth right now? In your opinion, what are some of the areas of most opportunity?
I definitely see that calibrating a lot of these sensors with ground truth is really going to be the thing that, you know, we're always looking for micro seepage for either environmental or for oil and gas or for minerals. So I see the democratization of the data is probably going to be the thing that really gets us over the next level, because the more people you have working with it in terms of processing the data and also establishing better correlations or calibrations with ground truth, I could see us do a quantum leap in terms of our efficiency, but that's my reading tea leaves.
Yeah, Dr.
Susan?
Pantano, is that mainly like with drone data, or are you talking about like having just better calibrated satellite data, or?
It's every sensor possibly. You know, on the Earth, we're getting more and more wireless, so you can have things in the streams. They don't have to be high quality. You can just have swarms of these things, and then you'll have the drones that might be able to hit at one level of resolution, and then you'll have the satellite stuff giving you the time series.
Okay.
And, you know, what the geophysicists have done, you know, increasing signal to noise. As soon as we start to have a lot more of these remote sensing, and I don't care if it's an aircraft, you know, an Estes rocket or a balloon, more and more of these type of things, the more that that data is out in the public domain and people start to see these correlations and calibrations, now we'll be able to know what ground truth is.
And do you have a particular like camera that you like for drone data to be calibrated? Because that's one of the biggest problems I've had with many customers. They'll bring me data that's just like from a Canon, and it's like, I'm sorry, I can't make radiance out of that.
No, you know, it's non-discriminatory that basically when you have a lot of data, it'd be great to have high resolution, but if you have low resolution, you know, if you know what you're looking for, it's easier to find it. So the equipment, the better the signal to noise ratio. But I really think it's having more minds looking at this, trying to solve problems will drive you guys to collect data that's more meaningful. You know, it's like, who wants to fly the same area every other day? You have to show that it's worth the money to pay for it to be flown that often, right?
Sure, but I think it's doable.
Yes.
Susan, Dave Koger had his hand up a few minutes ago.
Oh, okay. I didn't see. Thank you. Thank you, Dr. Davis. So, Dave Koger, would you like to ask your question or comment?
There's a broad audience, apparently, from drones to satellites, geostationary satellites, radar, and all kinds of spectra. Whatever somebody's interested in, I can't recommend more highly Jim Ellis's book with Floyd Sabins about remote sensing. It's got all the answers you need to know to get started to understand what you need to get your mind wrapped around. The marketing is a different thing. So it's not a done deal. Once you know everything in Jim's book, that doesn't mean you're going to succeed unless there's a market and you can, you know, seize on that. And I'll turn it back to you. Thanks, Susan.
Well, Dave, I really admire everything that you've done. You've been in the business for a long time and have had experience in so many different areas. What are some of the things that you see as areas of opportunity right now, in addition to the other things that have been?
Oh, I love the idea like John Roberts was talking about with the drones and making them autonomous and automatically doing this and that. That's the message that needs to get out to the market in non-military terms. This is what we can get done for you. And if you're looking for precious minerals or to manage your farm field better, corporate farming and all, I don't know what that had to do with your question, but that's one of the things that stuck out to me. The automation.
Yeah, because I think of that like there's all the precision agriculture.
Yeah, big market.
Yeah, we've looked at. By the way, we've looked at agriculture, and there's some real opportunities, but also some big challenges there. But and mentioning the non-military, one of the things I was very focused on was being very wary of anything that's got military or police state kind of capabilities, and trying to walk, stick to the commercial side of the equation, or research. But and that's a tough line to walk. But I'm really concerned about that in general.
Yeah, I will say from my experience in agriculture, number one, the MicaSense Red Edge sensor is a really good one if you're looking at vegetation, and sometimes vegetation covers geology and can tell you something about it. And it's very well calibrated and works quite well. So just a shout out to them. They do a good job. And then what was my next one? Ag for us as a industry, I mean, we sell to a lot of, pretty much any industry that's out there, but ag has been really soft for the last year with the sanctions that have gone on. It's dropped off tremendously. For us, we still think that there is a market for it in the future, because obviously you have to feed everybody in the world. But with the economic, climate as it is, it's actually been a really tough industry for us to be in.
It's challenging, and because we had a couple of guests a couple of weeks ago. They were talking about the challenges in agriculture. One thing that I'd like all of you to potentially comment on is the future in terms of local energy and site analysis. So let's say for an example, I'm in a community and I need electricity.
Okay.
I mean, I'd like to be able to get high power transmission lines across in the electrification of the US, but that's going to be several years. So in the meantime, I know that there are some geothermal potential areas around my community, also some low volume gas wells. And also I know where I can potentially put skid mounted server farms that can be right up to the electricity generating area. How does the use of surface information help me with those decisions and with that planning, with those plans?
All right, I'll take a stab.
Yeah.
I mean, I think that imagery it's kind of secondary in a lot of ways. Okay, so you know where your geothermal source is. You have to get lines through there. What trees do you have? What pathways can you get it to the end user the best? Is there encroachment on your lines? I mean, there's also drones that collect LiDAR. There's aircraft that collect LiDAR, and I think that's one of the modalities we haven't mentioned here. That can be a big player in doing sourcing for local energies, to understand the terrain and what you have to deal with.
I think in the world I've come from for the last decades, like I'm a professional geologist out of California, and in the end, the engineers run everything. They have all the money, they set the specs, and everyone should realize that, like infrastructure or power lines, all these things, the remote sensing, geospatial really plays into that. But when you get into the sciences where there's not an absolute answer, like geology or environmental, it's way hard to get money. But the engineers, you can do the same job, but you'll see that it's headed up by an engineering project. So I think hopefully, the government will say, okay, we got to fix the infrastructure. And that'll include power and energy and everything. And there'll just be, I think, huge opportunities for people to start to build geodatabases that use remote sensing imagery. Plus, like I think John said, all this wireless, all this information is just too much information. And this whole thing of big data, and oh my God. But it's just saying, okay, who controls the money? if you want to pivot, and it's the engineers besides the politicians, but and then the rest of us can flow along with that and do environmental or litigation or whatever. That's just what I've seen over the decades.
I see what you're saying, and I think that geologists have a role in that, just because of the understanding, say, the nature of the reservoirs, or the source of the energy, but also in this kind of integrative thinking, we don't have to give ourselves labels. we can be integrative. And think about what BP is doing. They're kind of transforming themselves into energy exploration and production as well as utilities. So just thinking it through.
You know, one of the things that I'd like to share is a lot of geologists get pretty good at geospatial stuff. And the USGS here in Bozeman at Montana State University, as we look at more of these things, solar panels, windmills, mining, these all sometimes attract wildlife and or migrating birds and stuff like that. And they're building sensors that actually are trying to avert things coming down and crashing into solar panels or crashing down into acid pits and stuff like that. And I saw, you mentioned BP. BP actually has drones that actually haze the birds away from trying to land where you don't want them to land. So as we get more and more of these distributed systems, there are some unintended consequences that technology has helped mitigate, at least that I've seen.
That's a really good point. I mean, it reminds me of the Tulsa airport back in the day when it was possible to travel a lot. I mean, what are all these bird sounds? They had sensors that whenever there were birds that would be detected, then the sounds of the cries of predatory eagles and basically bird calls would supposedly terrify any kind of geese that wanted to like climb up into an engine or fly into an engine. Well, so just wanted to thank everyone, and I will just ask each person if you have any final thoughts. Amanda, do you have any final thoughts?
No, thank you for inviting me, Susan. It's been an interesting discussion, and look forward to participating in the future.
And thanks. And Jim Ellis, I've just ordered your book. It's $89, which is an amazing price. It's really reasonable. I think that the second edition was that much. So.
What a deal. I enjoyed this a lot, and thank you everyone for participating.
And John Roberts, would you like to say a few words?
Just thank you very much. It was a great opportunity. I appreciate it.
Oh, no, thank you. And Kumar?
Yeah, thank you very much for inviting us. A lot of exciting things happening, and hopefully this was useful.
And John Pantano?
It's very educational. Thank you all.
Thanks. Well, anyway, so finally, the last word is for Dr. Davis. Would you like to put in some insights, give us some insights and thoughts?
Oh, I just sit back and get more fascinated every week. These were excellent presentations again, and I learned a lot. I go out at night and watch the when it's viewable, go out and watch the International Space Station fly over, and then the discussions about satellites and the things talked about tonight are just generally fascinating to me, although those are not my fields. But anyway, compliments to the presenters, and another good, successful evening. Thanks to you, Susan.
No, thank you. And I want to thank Mark Hemzat, who's been helping with a lot of the publicity as well, and organization for some of the technology things. And I also just want to mention that we do have a research assistant / intern, and I noticed that Camelia Balut is in the audience, so she's doing really well with working with that. And just want to thank all the people that are playing a part behind the scenes to make this a really valuable experience. Want to thank you, and want to welcome you for next week's presentations as well. So thank you, and wow, what a great evening. Bye, everyone.
Bye-bye.